exist in Europe. And you see, this is a typical sort of human habitation. It's like inside there's order, and outside there's chaos and barbarians, and then there's a couple of walls to keep the chaos and the barbarians out, and then inside, you know, there's a dominance hierarchy and everybody can live their relatively productive and relatively peaceful lives inside of that. It's all framing, getting rid of complexity, unnecessary complexity. Same thing with houses, they do the same thing for you. And then social institutions do the same thing too. It's like, okay, this is it Kennedy there and Obama? I think so. This is part of the transition in power from George Bush to Obama. And, you know, that's a pretty scary thing to have the leader of your dominance hierarchy replaced by another leader. And, you know, among chimpanzees, for example, that's often the occasion for a fair bit of mayhem. And it's also the case often for people that occurs. And, you know, we still have that in the form of political corruption and so on. But all things considered, you know, the power transition from Obama, or from Bush to Obama, was far more peaceful than such power transitions generally are if you look across the history of mankind. And so that means you're also protected by your social institutions. They screen out a lot of potential complexity as well, as long as they're functional. And also, I think, as long as they follow some of the Piagetian rules. And so one of the Piagetian rules for a playable game is there's some reciprocity. You know, you regard the system, roughly speaking, as either fair or fairer than any other system you can think up. You know, it boils down to the same thing, because if it's not fair but you can't come up with a better fantasy, well, it's as good as it can be. So the sociological or sociopolitical structures that keep complexity away from us can only operate under a certain limited number of constraints, but still they perform their function, you know, and very admirably. It's amazing, I think, because I see people in my clinical practice all the time, you know, and most people that I see, and I think this is true of most people in the world, have at least one serious problem. You know, and it might be they have an illness that's just god-awful, or if they don't have an illness, one of their immediate family has an illness that's god-awful, or they're really old and they need to be taken care of, or they're suffering from some insane economic problem, or they've just been unemployed, or whatever. You know, there's something in their immediate circle that's really, really difficult to grapple with, and yet people still go out and maintain their place in the world, and the whole thing roughly works. And to me, that's just a continual source of amazement that people can pull that off, you know. So anyway, so a lot of the screening that you do to get rid of that complexity is external, and part of that is a consequence of good, well-functioning sociological organization. Then the next thing that sort of screens things out for you is your body, right? Now look, you kind of naturally see things at a particular level of resolution, right? There's no obvious reason why that should be. So, you know, you see the front of people, you can't see the back of them. You see their external covering, their skin and their clothes. You can't see inside them. When you look closely at them, you can't see their cellular structure or their molecular structure or their atomic structure. You can't really see the social situations that they're embedded in. So if I look at you, I can't see your family. I presume you have one. I can't really see the political situation that surrounds you either. I have to know that abstractly, and then the ecological level is almost completely imperceptible to me. And so part of the way that complexity is screened out is that your body just doesn't allow you to pick a lot of it up. You're just blind to it. So you see at one level of resolution, and that's the human level. You see things of approximately our size. You see things that are approximately the size that we can grip. Those are sort of the things that you're likely to think of as objects. Like clearly a mountain isn't exactly an object, you know, so usability is part of what defines perceptibility. And so that also screens things out. And so then you're left with, well, what it is that you have to deal with once everything's been screened out. And then you might ask, well, there's still a lot of complexity left there. Like there's plenty of complexity within the average family. And there's plenty of complexity in the mating domain, you know, to find a partner and to establish a reasonable long-term relationship and to have children and to raise them. There's plenty of complexity left. And then the question is, how did biology, how did biology come to solve those problems, given that they're almost infinite in complexity? How can you do it? And the answer to that is, fundamentally, a Darwinian answer. You start simple, so that's back in the days of the one-celled organisms. We have no idea how those things got their start, right? I mean, the actual beginning of life is a serious mystery. And I'll tell you, it's such a serious mystery, this is completely unbelievable, but one of the people who discovered DNA, I think it was Francis Crick, in fact I'm virtually certain it was, he actually believed that DNA came from an alien civilization. He wrote a whole book about that. It's called panspermia, and so he posited that it's possible for DNA to drift through space for millions of years and to land on planets and to start living, and that God only knows how old DNA is, because he just couldn't figure out at all how it could have possibly evolved. So scientists are a lot weirder than you think when you start to read, about what the scientists who discover things really thought. They're completely, out of their mind. But whatever, we'll assume that DNA got there somehow, and then evolution took over after that. And so what does evolution do? It basically says, well, here's a terribly complex problem that we've sort of partially solved. And partially solved means we've lived long enough to produce another copy of ourselves. That constitutes the solution. That's it. So, we've lived long enough so that we can conceivably duplicate ourselves. How should we do that? Well, a variety of different ways. That's the answer. We should produce variants. So that might be multiple offspring, or it might also be facilitated by random mutation. Hypothetically, the mutations are random. Although there's increasing evidence, by the way, that organisms are much more complex at the genetic level than anyone ever assumed. And bacteria, for example, swap DNA back and forth with other bacteria all the time. And there are experiences that you can have that will change your genetic structure sufficiently so that you will transmit that to your children. So, the idea that everything's purely Darwinian and it's only mutation that drives randomness, that's clearly likely, but not complete. These other mechanisms are clearly there. But the issue is that what you do is you start with something that kind of works, and then you produce microvariants of it, and then the world around you changes a little bit, and hopefully one of those microvariants manages to do the same thing, and then it produces a bunch of microvariants, and then they manage to do the same thing. And so what's happening is there's an arms race between the environment, which is always changing, and the organisms that are trying to keep up with it, and that arms race just goes on forever, and different life forms proliferate as that occurs. It's sort of like life is always playing catch up, and you never get it right. You cannot get it right. The best you can do is get it right long enough to live long enough to reproduce. That constitutes the sum total of your knowledge. So what that means, at least in part, is that you guys are all the beneficiary, let's say, of a evolutionary process that's basically been going on since the beginning of life, and that's about 3.5 billion years ago. And so your body, your psychophysiology, has been in an arms race with the transforming environment for 3.5 billion years trying to keep up, and poof, you're the stellar consequence of 3.5 billion years of effort and death. So, you might thank the cosmos about that. You think about this, every single one of your female ancestors successfully reproduced. It's mind-boggling. It's mind-boggling. You're so unlikely that you would be here that it's almost incalculable. So,